Namaskar, this is Mrs. Neela Kalyan Jagdade and today we will be discussing the concept of closure when we have a signally plunging anticline which is cut by a fault at its crest or at its nose, and we have the down thrown block in a down dip direction. Yes, the figure of the contour map has already been drawn here, wherein we get to see the regional strike and dip. We have north that is marked, yes, and what we get to see is this is the F and F dash is the fault plane, yes, and we have contours, this being 70 at the crest of the anticline, signally plunging anticline. We have 60 meters, 50 meters, 40 meters, 30 meters, 20 meters, 10 meters and 0 meters, and then you have minus 10 and minus 20 meters, that is below the mean sea level. Fine. Now here what we get to see that 70 meters contour on one side of the fault is coming in contact with 200 meters contour on the other side of the fault. Yes. Similarly, one more thing, that is 60 meters contour on one side of the fault is coming in contact with 190 meters on the other side of the fault. Reason why we are discussing this, you guys already must be knowing, is because we get to find out what is the throw of the fault by seeing which contours exactly meet one another. Yes, and then what we do is we subtract the lower value from the higher value to get the throw of the fault. That's what we've done here. It's written throw of the fault is 200 meters minus 70 meters, which is nothing but 130 meters. Similarly, 180 meters is coming in contact with 50 meters. Therefore, you subtract 50 meters from 180 meters and the value that you get is 130 meters. Yeah. So, the throw of the fault is 130 meters here. But, guys, what we are dealing with here today is we have the down thrown block in the down dip direction. Yes. So, when we are talking about down thrown block in the down dip direction, it is like this. This is the fault. Yes. This is the signally plunging anticline. These contours, is representing this. This is the axis of the fold. Yeah, we are just, replicating it in 3D. Yeah, and we have the down thrown block in the down dip direction. Now, please understand one thing. We have the down thrown block in the down dip direction. Hydrocarbons are coming from the down dip region. We are talking about buoyancy and hydrocarbons being lighter in weight, they float over the water. That is nothing but buoyancy. Yes. So therefore, what we know that hydrocarbons are coming from down dip region. So here, what is happening is when you have the signally plunging anticline and the block has fallen down. Yes. Here, see, the block has fallen down. This is the throw of the fault. Block has fallen down. This is the throw amount of the fault. But because the entire structure has fallen down, yes, and this is the seal, only this part itself is the seal. No matter what, how much ever is the throw in this case will not matter at all. Please understand. Yes. So what is the closure dependent upon in this case? In this case, the closure completely depends upon the structure in the down dip direction. Now, what do we mean by structure? Please understand this. See, for example, this is case A. Yeah, those are the papers that I use, generally mostly to explain in 3D. Yeah, so this is case A and this is case B. Yeah, which one is steeper? Case A is more steeper as compared to that of case B. Case B is gentler. Yeah. So now what is happening? If we are talking about closure, what is it? We are talking about vertical dimensions. If that is so, which one will have more closure? Certainly, and more visibly and clearly we get to understand and see, and quickly the answer comes that case A, which is steeper, will have more closure because the vertical dimension here is more as compared to that in case B. Correct? Yeah. So now what is happening is because the steeper, this is the reason why we are talking about what is the structure in the down dip direction. The steeper, dipping or the more steep or more is the angle of plunge. Yes, more the closure will be. Less is the angle of plunge. Less the closure will be. So here it is. Supposing this is a fault. Yes, this is the structure. This is the axis of the fold which is dipping, and because it is dipping we say plunging. Yes, so the axis is dipping, therefore we say plunging. It's not, we are not talking about the limbs here. We are talking about the axis being dipping. The limbs are already dipping. Yes, these are the limbs, front and back, they are already dipping. We are talking about the axis dipping. Yes, so here what happens is the axis is dipping. Yeah. Now because the axis is dipping, Yes, we should be understanding one thing, that is the closure here will depend upon the structure, meaning the highest point to the lowest point. From this entire thing will be closure. You getting me? More steeper the angle is. Please understand this. More steeper the angle is. See this? Yeah, more steeper the angle, more is the closure. Gentler the angle, less is the closure. Is that easy? Yes. Steeper the closure, greater the steeper the angle of plunge, greater the closure, and gentler the angle of plunge, less is the closure. Yeah. So we've understood this. Now having understood this, we move further and we'll understand one more concept. That is here now that we've discussed that when we have a single plunging anticline which is cut by a forward with a crest, and you have the down thrown block in the downward direction, the closure will completely depend only on the structure in the down dip region. In that case, if we see, these are the contours. Yes, this is a contour map. So in this case, and this is the axis of the fold, these are the limbs of the fold, and the axis is plunging. So we've drawn here with blue color, this thing, this is the axis, the plunge. Yeah, that is mandatory. You guys got to be drawing this. Yeah, because structural is all about drawing figures, and I always, even in my lectures, whenever when we have lectures, I keep on telling you guys, be it whatever subject the thing is, just draw figures. Whatever you understood, draw it, because it just shows that you have understood the concept, and the teacher quickly knows that this person has understood the concept. Make your own figures and draw it. Yeah. So, and in structural you got to be drawing figures. It is completely figures, I'll say rather. And so here we go. Yeah. So we have 70 meters contour which is coming in contact with 200 meters contour. Thereby we come to a conclusion that the throw is 130 meters. But here in this case the closure does not depend upon the throw at all. So we are not concerned about the throw. We have just one case here. There is no partial sealing. There is only one case, that is completely sealing case. That too, which depends only upon the structure. The closure depends on the structure. So here what is happening is, the lower boundary is a closed area, which we show by green color mostly, will be at what meters? Will be at 0 meters, because at 0 meters itself, you see this contour, it ends. After this there is no contour that is meeting the fold. So the last contour that meets the fold is 0 meters contour. Thereby we can come to a conclusion that the lower boundary of the closed area is at 0 meters. Yeah, and therefore we write here, this is the lower boundary of the closed area. Yeah. So yeah, that being understood here. And how much is the closure now over here? The closure is nothing but 70 meters to 0 meters. We subtract lower value from the higher value. So 70 meters minus 0 meters here is nothing but 70 meters. Therefore, the closure in this case is nothing but 70 meters. Yes. So this was the concept of understanding what is the closure when we have the down thrown block in the down direction, when a single plunging anticline is cut by a fault. I hope this is clear. I'm sure it is clear to you guys. Yeah. Thank you. Have a wonderful evening.